Hello, it's Keith from Kinvert, and we are going to be talking about the degrees of polynomials. And so a polynomial is basically an equation that's going to look like, x to the third plus 4x squared minus 3x plus 2, just for an example. Okay, we want to find the degree of the polynomial. The degree of the polynomial is whatever the highest power is that's going on in here. So, for example, even if we were to rearrange this, we could say, and I'll just kind of make a new one, but 4x squared minus 3x to the fifth plus 2x minus 5. In this case, the degree is this 5 here because it's 3x to the fifth. Even though this is negative, right, this is still to the fifth power. This is a fifth degree polynomial. So what are some other examples? What are some real world examples? Let's look at that. So in engineering and in physics, a common one is if you are looking at a building, for example, and you're going to treat x as kind of down, but let's say that you're standing on a building and you drop a ball. Okay, so right now it is at x of 0 for its position, and x of 0 we'll just treat as equaling 0. And since you're holding it in your hand, the initial velocity, which is v0, is also 0. The acceleration is 9.81, and that's in meters per second squared. This is in meters per second. So let's look at the function itself. X for any given time, so x is a function of time, equals half a t squared plus v0, which is the initial velocity, times t, plus the initial position, so x0. What we're looking at, so this is a function of time, and we've got our constant here for the first term, and that's half a, which is going to be what, it's going to be 4.9. It's going to be like 4.95 or whatever. And then you've got your t, that's the actual variable that we're looking at here, and that is squared. So this is at least a quadratic equation. All right. Now we happen to know later we're looking and there's no higher terms. Okay, but this is a quadratic equation. Then the next one, this has a degree of 1. This term has a degree of 2. And this term has a degree of 0. It's just a constant. Okay, so these are the coefficients. Coefficient, a constant. This is the variable here, t, and the highest degree is 2, and that makes this a second degree polynomial, second degree, which makes it quadratic. Am I going to spell this right? Quadratic. So this is a quadratic polynomial because the highest power is 2. And that's the same as over here. Here the highest power is 3. That would make it cubic. Here the highest power is 5. That would make it quintic. You can memorize those somewhere else. I guess the main thing is to just help you find what's the highest power, what is the degree of the polynomial. So I'll give you one more example here. We'll have 5x plus 3x minus 7x to the sixth plus 4x minus 5. So what is the degree of this polynomial? Let's give you a sec to think about it. Time's up. So first one, this is a first degree. So that's a 1, that's a 1. This one's a 6. And then a 1, and then a 0. The highest is the 6th, so this is a 6th degree polynomial. Alright, so I hope this made sense. Here is kind of a real-world example, and in the future we'll go over how to actually directly use this and solve for things, which is going to be pretty cool. But here's an example. You might always look at polynomials. Why am I learning this? What's the point? Well, here is a real-world example I've used many times getting my engineering degrees, and this is useful in real life. So, this was Keith from Kinvert. We went over the degrees of polynomials, And I hope you found this helpful. See you guys later. Bye.